Welcome to this short Oracle video. Today we will look at a real-life use case to see how our Oracle IoT Asset Monitoring Cloud solution will help monitoring AGV train. AGV stands for Automated Guided Vehicle. Our Automated Guided Vehicle train is used along a car assembly production line. AGV are moving around cart of parts between the part fulfillment area and the production line. The AVG track is marked on the ground by a line with a RFID tag placed every 2 to 3 meters. The AGV and their cart are moving along from tags to tags. The AGVs use Wi-Fi to report the status and last tag being read to the central controlling and monitoring server provided by the AGV manufacturer. The manufacturer provides a monitoring solution which is not matching the customer need, which is why we use our IoT asset monitoring solution. The customer need: being able to have a real-time monitoring tool of the whole IGV track, operators to be notified in real time of incident for faster intervention, and last, being able to have a trace of the incident and intervention being performed to have lesson learned information. The proposed solution, as I said, is based on the Oracle IoT Asset Monitoring Cloud solution. It starts with a dedicating software module which is decoding the network frame exchange between the AGV and the server. So it is extracting the last RFID being read to identify the IGV position, extracting the incident reported by the AGV, and the FPV status data such as charging tension or tension delivered by the battery. The information then is sent to Oracle IoT Asset Monitoring through MQTT queue, and IoT Asset Monitoring then is able to display in real time the AGV position on the track, the display metric collected by the AGV, the incident reported by the AGV and the processing status, the definition of and the display of the GFN used to define intervention area and the responsibility of each operator. So each operator have responsibility of one specific zone, and it's where he should act to solve the issue reported by the AGVs. We'll see in the demo that there is 3 zones assigned to 3 different operators. IoT AM using the Twilio platform is also able to send SMS of an incident to the right operator, matching the zone where the AGV is, to allow him to do a quick intervention. The operator is also able, using the standard IoT Asset Monitoring mobile application, to acknowledge and update the status of his processing of the incident. And finally, using the dashboard provided by IoT Asset Monitoring, we're able to have a view of the incident and the processing status. In summary, the solution benefits: an up-to-date vision of the localization and behavior of all the AGV from the train, a faster reaction from the operator to work on solve the incident, have a full history of the incident and the strategy used to solve them, as well as of the AGV having the most or the least incident. And it also opens the road to be able to use predictive maintenance for AGV on charging batteries, for example. The proposed solution, Oracle IoT Asset Monitoring Cloud, is one of the ready-to-use IoT applications provided by Oracle. Each of these applications are defined to solve vertical use cases, such as monitoring assets and all the related information. There is also production monitoring, which is more used to monitor a full production line within factory and be able to compare the performance of the different production line within a factory or between different factories, as well as manage incident of the production equipment. Fleet monitoring, which allow to monitor shipment and vehicle behavior. Connected worker, which allow to monitor isolated worker health and be able to help isolated workers at possible issue. And finally, siren monitoring for connected asset, which allow to automate asset monitoring and link that to customer service interventions. All these vertical solutions are developed on Oracle Internet of Things Cloud platform, which allow to provide the technical solution to be able to connect the device and the sensors that provide the information to the application, be able to analyze them, to integrate them with enterprise application, and incorporate machine learning for predictive analysis and anomaly detections. Let's move to the demonstration. So here we are in Asset Monitoring Cloud Service global view. We have modelized the shop floor where all the AGV are moving along. And here we see the AGV moving along, but they're all aggregated to give us a global view. So there is 20 located AGV that we can see here. There is currently no incident, and we can zoom in to see the detail of the AGV, and then we can see each AGV by number. So they're numbered and identified by number, and we can see the AGV. So the track is in red, and the little green flags are the RFID tags marking the track of the AGV train. Within the global AGV track, we have defined a geofence for different zones to define the responsibility of different operators. So let's display all the geofence. Here we are only the zone 2, but we can display all the different zones. So there is 3 zones. The zone here, which is the zone 1, the zone 2, and down here under the zone 0. Let's remove the geofence and to have a clearer view. So for each of our AGV, we have their instant location and real-time movement being identified. If we look at the 1291 AGV in our sample, you can see that we have some basic information and what are the data reported, the last position known, and so on. We have some connection, utilization, and availability metric if it's available. We have the tension, so here it's 25.5 because it's being charged. So it's in zone 2 and it's in a charging zone, so it's being charged. So it's kind of the max level of tension. If we look at the sensor information, we'll see that the tension is moving up and down based on the charging position the AGV is located at. So now the charging is finished and it starts moving. Now we have seen our AGV moving around and sending data to our system. Let's see about how this information is fulfilled into our solution. So since we were not able to connect directly to the factory shop floor, we took some data and we used our digital twin simulator to inject the data to the solution to have all our AGV moving around in semi-real condition. Digital twin simulator is sending information about the last tag being read, the tension, the status, and so on, and is also able to simulate any condition the AGV could report. So let's say that he has read an unexpected tag. So what's happened is that we're creating an event for our AGV, but also at the same time we're sending a new SMS to our operator. Where he gets an information that today at 4:31 there was a new incident created. There was an unexpected point being read, which is the error 10 for the AGV 1291 in zone 2. So the operator of zone 2 just got this SMS. What he can do now is can start his IoT mobile application and review what's happening on AGV 1291. And he can see that there was some incident before, but there is a new incident available at the bottom of the list. So what he can do is can click on the incident to have a bit more detail about the state. So it's a new incident, the priority is high, it's a type of outage because the AGV is lost, he has missed one of these points. So he can decide to go on site and acquire the incident. So the incident is open and is assigned to him. So the status has been changed from new to open. Now what he can do is to be on site and work it out. So a work in progress. So what he will do is to add a comment saying, so we have seen that the status have changed, and saying that he has put back AGV back on track. So the information is documented. If I go back to my information now that the AGV is back on track, what I can do, I can just mark the incident as resolved. And now all my incidents are resolved for this AGV 1291. Now that the incident is resolved, we can move back to our global view of our AGV chain, and we can search using one of the built-in features for our AGV 1291 to see where he is and what is his status now that his problem is totally solved. So here we are. We can see the detailed status of the AGV, which is running fine, and have the list of the incident and having the one being solved at 4:34 by our operator just over the white line. Just to give an overview of how the incident work, let's move back to our digital twin simulator, and let's simulate another incident like unexpected point with skipping one of the reading. So we'll generate that incident. We'll see that now our AGV will be marked as being one incident. So if we remove the search and click on the incident number here, even in aggregation we can really clearly identify which AGV has an incident. And in the detailed view we can see that there is a new incident at what time it occurred, and we can be notified that way that the incident just happened. If I move to the global view, what we can see also here is all the reporting about incidents. So if I go to the incident tab, here I have a reporting for all the incidents that occur on the different machine, but here again I can filter to show only the incident by status or by name or by summary. So here I will use my AGV 1291 and only get the incident for my AGV 1219 and the detailed information about each of the intervention being run. So the last one here on the 30th of October, I can just edit it and get the information about what have been done with the transition and the fact that the AGV has been put back on track. As we have seen, we can have the detail of our incident being resolved, and I can export that into Excel format. I've seen that we can export the incident list and the status of the different incident and the date and time reported to be able to process them in a back office manner, consolidate them. To finish, we'll move to the dashboard, so we can create a personalized dashboard where you have really global information about resource being used, the availability, the connectivity, and so on, and also all the summary for all the incident being recorded, anomalies and predictions. Thank you for listening. That concludes our presentation.